Okay, greetings everyone. This is Eric Andelin, Senior Workflow Development Specialist with SimActive, and you're here for our webinar, Managing Large Corridor Projects Using Distributed Processing. And with me, I have my guest, Peter Rauhakallio. Is that correct? Close?
Yes, it's very good.
Okay. VP of Business Development at Sharper Shape, and Petri came along to us through one of our partners. They are doing some fascinating stuff, and Correlator 3D is kind of the base of that. So I wanted to bring him on and kind of discuss the bigger picture, what they are doing in the world of geospatial. So, Petri, say hi.
So hello everyone. Happy to be here in the webinar. Nice stuff you
So
guys are doing at SimActive.
happy to have you join us. Really appreciate that. I know we've got a little bit of a time zone difference, but we're still close. Still daytime in your world and daytime in our world. So that's fantastic. Tell us a little bit about the company and your role with the company.
So yes, we are Sharper Shape and originating actually here from Finland, established 2013. And I have been actually pretty much from the beginning involved on board at the company. And our starting point since back then when we started was to start solving challenges what utilities had as they had collected a lot of LiDAR data of their networks and how to efficiently to utilize all the data. So the very much the starting point was to automate vegetation analysis for utilities here in Finland, and make it efficient to utilize all the data they had already collected.
Fantastic, fantastic. So, and I guess what brought you to our attention was the size of the projects you're doing, the technology that you have to use to efficiently process that data, and then again, like you said, we're running into what we're calling digital twins, and in the computing power and the storage space and the ability to use AI to pull that information out. Fantastic stuff. So before we get started, I wanted to mention the topics that we're going to cover. And again, they are challenges in managing large corridor mapping projects, because on the utility side, most of the projects are probably big corridors. Running correlated 3D in the cloud. So that's something that's unique to our power users. Advantages of distributed processing. We've got to talk about that. And then, potentially time savings with scripting and rolled up into all of that. So give us a little bit of information about, what your clients are looking for, how you do it, scope and size of a typical project.
Yes, sure. When we started, we actually realized early back then that actually we need to enable the data capture, have a sort of sensor system to collect all that data and provide our inspection services as turnkey solution to our customers. Here in Europe, the needs were originally, as I said, vegetation analysis, and secondly, by utilizing captured images to be able to accomplish component inspection. I mean, conditions of corridor, assets, poles, its details. So that's where we started. And to continue, since 2018, we've been working and focusing a lot of our efforts to US and namely in California, where actually we then opened first of our big programs, inspection programs in California for our main customers, tier one utilities. And the same paradigm applied by the time. So capture the data to be able to manage the whole process, the whole inspection program, collect LiDAR data, process it into a format which enables accurate analysis. I mean, it's about that what you feed in, the quality of data, that quality of analysis results you can equally get. And during that journey, we've been forced and been happy to learn a lot about specific land surveying methods, what needs to be applied, for example, in California, because the land is moving. I mean, the continental plates, they they are alive all the time, and that kind of coordinate georeferencing processing we have needed to take into account and developed during that time. So many years now we've been working very closely with our main customers in California.
Very good, very good. So I don't know if you knew this, but I grew up in Southern California, so I'm very
Okay.
familiar with survey and in California and all the zones, and been through
Oh,
quite a few earthquakes myself, so I don't miss it. Uh, but
yes.
I do understand the importance of the utility companies being able to continuously provide power to their customers when you have scenarios such as earthquakes, lately wildfires, all kinds of things that can potentially take a system down. And the
Yes.
goal of what you guys are doing is trying to make it so that, one, to prevent that from happening with vegetation encroachment and things like that, but two, also, if it does happen, how to minimize it and get it back online as fast as possible through the digital twins and in the documenting of all of the pole related information. So um, it's a huge task, and it's fascinating that you guys do that. So you're collecting all of this information with helicopters and aircraft and perhaps drones. Is that correct?
It is correct. So, for the purposes of large inspection programs, we've actually developed our own sensor system, which then can combine LiDAR data, of course, with all navigation data required, as well as we have a phase one high resolution 100 megapixel cameras to capture every asset from front and backward kind of directions. And as well, we applied hyperspectral cameras in our sensor system and accomplished a project where we detected 3 species in California as well. So that was a very interesting journey as well, as the vegetation looks like a bit of different compared to Europe, Northern Europe, Finland, as
Mm-hmm.
to compare. So
Mm-hmm.
a lot of stuff around that, what kind of data to capture, how to make it usable, how to process the data for the analysis. So that comes from our sensor system. And as you mentioned, yes, we also apply drones. Drones have been used mainly for component pole inspections for such programs to be able to document very accurately the pole conditions. And of course, drones can be equally used for other data products like orthomosaic production as well. So that comes along with that. In the end, actually, we are sensor agnostic, so we don't need to process only data captured by our sensors or drones we are familiar with, but we want to adapt different data sources, and there the data quality, its assessment, quality assurance becomes, of course, important, and including like satellite Earth observation data as well, to be able to complement analyses and extract different features such as change detection all the time. So,
Right.
so what kind of frames?
You mentioned there's a lot of lidar. There's imagery. There's multispectral. It could be captured from helicopters, aircraft, drones. I would imagine mobile LiDAR, it really doesn't matter, but
Yes.
you're collecting a comprehensive data set of that corridor in, again, large scale. We're talking about the state of California. We're talking about a entire utility network. In Correlator 3D, we're an image processing software. So we're a component of what you do. We also, ingest and process satellite data. We ingest and process multispectral data, and we can bring in LiDAR where it helps to speed up the process. So
Yes.
I understand, how we ended up, being a part of your workflow. We're just a part of it. A lot of the fascinating stuff happens way beyond what correlated 3D does, but it's kind of in your process, it's kind of a place where everything goes to start or gets merged to start and then becomes, the big product that everything is pulled from. So very interesting in that. So is there, for your clients, is there an environment that they can pull this information from? Is it a viewing tool? Is it, what is the product that faces the client and they can get their information?
Yes, very much following what you said just previously. So different data sources, how to combine all that, how, for example, SimActive tools can enable that. The value comes from the data and how to use it. So typically these projects we've accomplished, they have specific goals, deliverables, and it can be related vegetation analysis. I mean, namely to be able to provide where are the threats, how far they are. We can attribute exactly how close or what is the proximity of vegetation issues. Secondly, we create engineering modeling of the network itself. I mean, for all the poles, its components, wires, support wires, guide wires, how to say, all that. And thereby as well, we deliver very much complementing data products such as orthomosaics. And with all that, the planning for the network maintenance can start. And along with these projects, we've developed our digital twin platform, how we call it Core. It's Amazon Cloud operated platform where we then ingest the data and actually make it available to our customers for efficient use. And the beauty of delivering data really comes from the cloud computing, cloud delivery, as the system can be accessed anywhere from the world very fast. The data representation, what we offer, has been optimized for online use, and even can say that by using just mobile broadband, my phone as the internet connection, and with my laptop, I can fluently browse that all data, visualize it. It comes to 3D rendering, how that can really populate fast on the screen, even with limited internet connectivity. And as well, then what comes to rendering images, and there then to be able to provide different zoom levels for the use of the data. It can be images as such of the components, or then orthomosaic layers, where then while you zoom in more, then more data is dynamically loaded to the screen, and that's how to enable then fluent use for distributed utilization of the data.
So, I mean, really, a digital twin is brought about because of the need for rapid information different information for different parts of that organization who may be looking for something that someone else is not looking for, but it's just as important. And the ability to bring that up on a mobile device or on a computer screen from anywhere in the world, it just makes it so decisions can be made faster, corrections can be made, vegetation can be monitored, moved, and all of that. It happens at lightning speed, as opposed to, here, I need a paper map, print that out for me, get it approved, this and that. You've got a better system through a digital twin in the way you guys deliver it.
It is exactly so. So paper maps sometimes needed for the field work, or then it's some other application, field device. We also developed actually iPad application front end to our digital twin, which can be used in the field even without network connectivity, that you can there download before you go to field the area and its data, and then it's even accessible there in the mountains where the network connectivity may be only occasional.
Exactly.
So that can be also it. So data availability, access to it, optimizing the network, the use of the data for different use cases. That's about it. It is not anymore about hard disks or something else what you need to find through your index. Now I want to see the environment point cloud or orthomosaics of this spot where I'm interested in. We have rather contextualized all that data, so you navigate there through your assets. Yeah. So you know the pole ID, then you search it, then you get all the data, also the historical related to that spot. So that's how to make it usable. And what I can see, this has proven to be quite efficient. Our biggest customers have thousands of user seats to our digital twin platform. So it is heavily used.
Very good, very good. So let's talk about challenges in managing large corridor projects. And when we talk about how large, you've given me a little bit of information here. 3 of your inspection programs here in the U.S., 34,000 miles of corridors,
yes.
8 million nadir images. So we're talking about a big set of data, not to mention the LiDAR and all that goes with it. So, what challenges do you face in processing these type of data sets?
It is so much about the data and its volume, because it is a lot of that. The procedures need to be, first of all, efficient, that we know in which order, what are the units, how to process the data, kind of area by area. In utility world, we talk about circuit areas, which is typically kind of the analysis unit. And kind of one starting point, what comes all in all to this is that, for example, now if we talk about this orthomosaic data production projects we've accomplished, exactly as he said, 34,000 corridor miles, 8 million nadir images. Originally, the data capture program, the big one we started 2019, it wasn't designed to produce orthomosaics as such. Yep. So the flight pattern itself just follows the corridor and the power line. There is some loops here and there. When there is more kind of tight urban area network, there might be even a lot of more loops associated. Thus, the flight pattern itself, it didn't support that. Now we are targeting to produce orthomosaics over this area. Then it comes to image coverage. They overlapping, and we can say it's barely enough.
Yep.
And sometimes to get the coverage for orthomosaics, it can happen that the coverage is only completed with images which come from angle. And there was a lot of that kind of study we needed to do first to understand the pattern of the characteristics of the data in order to be able to produce quality orthomosaics for the data deliverables.
So what you're talking about is, to be efficient in what you're doing, you most likely want to fly a single line down that corridor. You know, because 34,000 miles becomes double that if you have to fly too many lines. And the way you solve for that, I mean, if you fly a single line corridor with just one camera, it's a challenge creating enough overlap and side lap for the AT to work, especially if you're going through turns and things like that. But if you then change to a multi-camera system where you've got a little bit off nadir, or you've got coverage between the two, then all of a sudden that works. And you guys, you know, thought about that and realized that was the case, and you're off to the races, and that's how you can handle, at least on the acquisition side and the orthomosaic side, creating data sets that large efficiently.
Yes, it has been so, and even at the same time for the biggest program, we've had parallel at the same time 5 helicopters, 5 sensor units at the same time surveying the network.
Yep.
So it comes a lot of all that planning, even that we do it consistently, area by area for each unit, scheduling the flights, all that. And then secondly, managing all these data volumes efficiently, that we do not lose, because if you just play the kind of playing card game of these SSDs to store all the data and eventually be able to process it, not manageable. Need to be clear processes, data consolidation tools to enable all that, and that all we have needed to develop for purposes of these kind of big programs. And of course, it comes as well to be able to, on the fly, I mean, during the data capture program, efficiently data quality, what comes to data coverage itself, as well as the data quality. I mean, what are the image exposures, not overexposed or under, and so on. If there is too much miss, then we need sometimes to refly such areas.
Yep.
So these big programs, they volume bring different kind of challenges compared to a small unit of area to be captured. So
yeah, most people think of mapping projects as, you know, this is going to take me an hour or a day to fly or something like that, which is great, and some projects are that way. But when you start talking about an entire state and corridors and having to have the right sun angle because you're going through mountains and valleys and all of these things, all of a sudden what you have a lot of temporal conditions that you have to account for, not to mention permission to fly and all of those things.
Yes,
it becomes a massive challenge. So
exactly.
Kudos to you guys for doing that. And also, I'd also like to mention that you are capturing LiDAR data here as well. So you've got, high accuracy, airborne GPS, IMUs, along with all that imagery, which helps the imagery, obviously, but it's more to manage. It's more data to ingest. And as you say, you can play the swap SSDs situation all the time, but you also have to know how to do it efficiently, because you don't want to be landing all the time for various reasons. It really is a challenge to project manage something like that. So impressive. And then you talked about the solutions leading into cloud processing, distributed processing. So setting up a scalable processing solution. So a little bit about that. How did you guys come up with that? Obviously, your data sets are so big, it's going to have to be in the cloud at some point.
So yes, it is about the whole data flow, all in all, from the data capture area by area, to be able to then kind of package single flights into entities, circuit area data. I mean, one circuit area can consist of, it can be 15, 20 different flights to capture it fully when the corridor miles are long. Then along with that, we go into our, of course, the data quality needs to be assessed, that we are on the ballpark, we have all the data needed and with the quality. Then we go into the processing, and LiDAR processing is kind of the baseline there to do, of course, to process the LiDAR and to be able to make it consistent. And as we fly many times, even by different flights or the same spot, the LiDAR can bring a bit of different results every time. There needs to be that kind of alignment to be accomplished. All these procedures we have a lot of automated, because otherwise you'll be doing the data processing long. And from the LiDAR, of course, we capture the DTM DEM for the like orthomosaic data processing, because that becomes, of course, the reference level for the land surveying grade mapping quality orthomosaic production. And along with that, there has been always land surveying, I mean ground surveying, ongoing, to be able to produce ground counterpoints for the project, which then of course refers back to the data. Its details like checkpoints from a known location, characteristics of, for example, asphalt or stop sign there, and to be able to see that, hey, we are on the par within the quality standards, I mean Californian ASPR standards for the data quality. So that all is step-by-step processing, and we need to have these quality checkpoints that we know everything is all going well. And then sometimes some process steps need to be repeated in order to get and match with the quality standards. So it is huge work we've done, and pretty much the only way really to be able to accomplish these kind of large programs, which have significant volumes of data. So,
So you guys have multiple licenses of Correlator 3D so that you could do this, and a lot of our users, the majority of our users, are large format aerial mapping companies. So they're used to doing fairly large projects. They do statewide projects. They do things like that. But a statewide project is pretty easy lawnmower pattern stuff. The state has a tile grid. They know what they want. It's not the same as doing, a meandering corridor through a state. So it's a bit different. So a lot of our users, although they may be dabbling in the cloud, they can probably handle their stuff on a local network, with multiple systems doing distributed processing. You guys are doing something bigger. So just give the users an idea of, what it takes to set up Correlator 3D in the cloud for you guys.
Sure. So for us, yes, we could do all the processing on desktops. I mean, do the ortho rectification part of each image on the digital elevation model level, mosaicing, and then exporting. Because of the huge data volume, we kind of need to be able to push all the time, that we have the process up and running all the time automatically, that there is no manual intervention to be able to, when this process has been accomplished in the middle of night, that somebody would be then again creating a new data set and starting that processing. I mean, we would be still likely processing all the data we've accomplished.
The file transfer alone would kill you.
So then what we've done, we've actually integrated your tools, Correlator 3D, into our cloud platform. I mean, our processing pipeline, so that it's a seamless part of our processing pipeline with scalability, with multiple instances, and triggering new processing areas automatically. We can just push them into the queue, prepare them all there, and once the previous area has been accomplished, then a processing unit, what became free, starts the next task. And what we did, we actually set up a bunch of like 5 parallel Windows virtual machines on Amazon Web Services, and kind of beefy machines to be able to accomplish their tasks efficiently. I mean, enough CPU, memory, orthomosaics, of course, requiring a lot of just
CPUs and GPUs. It's going to keep them busy. Yep.
All that. And then that cluster was there ready, and which we could kind of command through a load balancing for each next processing task seamlessly as we go, and keep the pipeline busy all the time.
Yeah. So how different is it between you doing it in the cloud and doing it on a local network for you guys?
So kind of the pipeline we created could be accomplished and set up on a local network on server machines under our desks. Yes, possible. But then the scalability becomes the next big challenge to say. What we developed into our pipeline is on-demand scaling for different processing steps.
Okay.
And we can then dynamically set up new instances for specific processing step when it's needed. And of course, we can think of AWS has infinite processing resources for us to be able to accomplish our big projects in time. So there comes the benefit.
Okay. So just little things you had mentioned that, long path file names don't work. You've got extra effort in monitoring processes, making sure that things don't fail. I mean, we like to tell our users that no matter where you use Correlated 3D, whether it's 1 license, whether it's 5 licenses, whether it's on the network, whether it's in the cloud, Correlated 3D works the same. It's just a matter of how you have to deal with that cloud service. You don't want to be using cloud service that's going to turn off your machine, or a service that's promised you GPUs and you're not getting GPUs. Those things, those are the typical challenges when you work in a cloud. But again, at the scale you guys are working, I'm sure you get the Cadillac of service from AWS and things like that. So you did mention, and we'll get to it here in a minute, a little bit about how you guys create routines to continuously keep the pipeline going through scripting. So we'll talk about that a bit as well. But we also talked about distributed processing. So Correlator 3D is unique in the image processing world in that we do have distributed processing set up, and you can, as you said, control a bank of machines. So if you have 5 to 10 licenses and they're all running Correlator 3D, and you can assign tasks. So you could say, I want AT done on these 3 machines, and I know that ortho production is going to take up this much resources, so I want it done on these 5 machines. And when one finishes of those 3, I want it to move over to this task. So I assume that's what
Yes,
you're talking about when you're distributing those resources around.
absolutely.
Yep.
So to be able to dimension, of course, do our own forecast, how much we think we need instances, SimActive Corridor 3D licenses to keep that processing capability busy. So that's kind of the optimization that, of course, we could have set up even much more instances there, but then likely many of them had been just
would be idle.
empty. Yes, idle. So because this orthomosaic processing was actually quite later in the steps of our whole pipeline. We already had processed trajectories. With the trajectories, we process kind of pretty accurate angle information and projection info for each image.
Yep.
And when that is done and we know that one area is complete, then we can set up for each area, for each circuit area, which is one deliverable, kind of the project for Correlator 3D to be able to, okay, now please process this area, and we know what images to be used. So that's kind of the assignment on that step. And when we kept all the time the pipeline busy, that there is also always new circuit areas waiting for the processing. So then we fed them into the Correlator 3D as instances were free to process them. So that's kind of the dimensioning of the processing pipeline. And I know further we talk and further we also with you guys check in for the details, what we did, how we found and made it working. So I'm sure there's spaces also for optimization.
Yes.
To be able to make it even much more fluent.
And honestly, I mean, that's how Correlated 3D is improved. It's feedback from you, the customers, that are, really pushing the limits of the software.
Yes.
And again, it's all about optimization for you guys. It's all about, because the project's so big, you need to have efficiencies in the whole process. So yeah, that's very very important. And the last thing I wanted to talk about a little bit was, and you mentioned it, once you have an area ready to process, you've got your surface has already been created through the LiDAR. You've pulled all of the angular information from the trajectories that were used with the IMU and the LiDAR and sequenced those to the images. So now the AT process goes pretty fast. You're using phase 1 cameras, which have a lot of dynamic range. So you have quite a bit of correction capability in the mosaic step. But from one area to the other, the steps are the same. So you've probably, as you work, you refine the process, which becomes a script, which, again, nobody is actually pushing a button really or looking at the workflow. The script has been already created. It's set and ready to go. And when the computing space is available, it's just point the data to those files and let it process, correct?
Exactly. And once all the data processing is integrated to our cloud environment, then all the input into the process happens automatically directly from S3, and as well then the deliverables, the tiled orthomosaics are written in the right folder in the right formats. So all that then happens automatically, and then furthermore, our delivery procedure for these data products is equally automated. So it becomes that orthomosaic step seamless part of that whole pipeline. And that's actually the beauty of how to use it here with the APIs, to be able to command and just to push the pipeline through.
Yeah. So I would assume in these visualization, not visualization, but in the apps that you provide your customers, in the tools that they have to access the data, I would imagine, do they have access to the raw LiDAR or the process LiDAR data?
So we provide access also to the raw LiDAR, and through our digital twin, that user interface, we provide visualization of that, let's say, optimized visualization of the raw LiDAR with classifications, all that. So they really need to then access the actual raw LiDAR LAS files, but to use it through our user interface.
But they're going to look at the point clouds, and I would assume, like you said, they're classified. Are they colorized as well?
Yes, absolutely. So then we visualize it for the spec what the customer needs. So we have then two options actually, and we provide the both. So we can color the point cloud by using the specific classification of engineering requirement-based classification of the power line, its components, wires, and all that. Or then the LiDAR coloring can be based on the orthomosaics.
Yep.
So then it really can provide very realistic view, 3D view into the network, and that's actually powerful.
Yeah, because we're used to looking at images. We're not used to looking at points. So the fact that somebody can see it in color and see, am I looking at a part of the utility, or am I looking at vegetation that's encroaching on it? It's just super easy at that point. You can.
And that comes, so there's many stories to tell, what we heard from customers, how they thought they can start planning their vegetation, for example, vegetation or engineering planning activities. Somebody thought, hey, that now the point cloud is the way to go. But actually from there, you cannot necessarily catch up everything. You need to have, as for reference, at the same time, view on RGB image of the pole or orthomosaic to be able to understand on, let's say, 3 different views what I have now here, so that I don't need to go access to the field to be able to ensure, can I plan this activity or not?
Yeah.
So that's kind of the seamless combination of different data formats, which brings typically the value. One alone is not necessarily enough.
Give us a little bit of information. Where are you guys going next? What's more aircraft, more projects? What's next for Sharper Shape?
So absolutely, we find value on our Gilfin software. So that's where we've been focusing a lot, and more we work with customers. Sharper Core, our platform, becomes kind of integrated part of the utilities IT architecture. What are the interfaces? What are the use cases and processes they can utilize our software capabilities for their planning, maintenance planning, and investment processes. So there is the value, and for example, here in Europe, the recent years, just 1 or 2, the market environment in the utility sector has been changing a lot. Demands for renewable energy sources has become more and more higher, or get rid of fossil energy sources, things like that. So the digitalization of utility networks, its importance is becoming much more higher. And there is always 2 areas. It's about the maintenance, how to take care of the existing network, how to put your OPEX money in the best possible way to invest into your network distribution reliability. Or then it is about investments, how to develop, how to build new features, new networks. So that's kind of these are the areas where we are and we want to be involved, and we see value where we can contribute.
Very good. Well, I know we here at SimActive are very happy to be a part of your solution. I appreciate your time and your sharing your stories with us. Petri, thank you very much.
Thank you, likewise. Happy to be here, and as I'm land surveyor as my background, so this is kind of close to my heart what comes to data, data production, all that kind of stuff. So happy to be telling our stories, and it's been a pleasure to cooperate with you guys. So that has been fruitful.
All right, thank you. And to all of you that joined us for this webinar, I'd like to thank you. If you left a question or have a question, we will respond to those as soon as possible. Again, I'd like to thank Petri for joining us, and a reminder to everybody that this webinar, as well as our podcasts, are available at our website, simactive.com. Until next time.